Hi guys, today is our lesson 4 whereby we have been modeling real life examples in Simulink. And today in our lesson 4 I'm going to model this battery, and from this battery model has a time varying load that is connected. In this scenario I'm going to use a variable resistor that is connected to a battery of 100 voltage. And from here, we want to determine the voltage drop across the load, the power, and the charge. We are going to assume that the battery has an initial battery charge of that 3 amperes hour. Therefore, we are going to conduct a simulation. After some time, we expect this one to reduce the charge, and we are going to determine the charge. Let's now have fun. I've already opened Matlab here, and the first thing we need to model the battery here. Okay, now you usually go to library browser. We are using a Simscape foundation library. You go to electrical elements. We know that a battery has 4 elements. We have a resistor that we need a resistor. Let me first have all the blocks. I will illustrate one by one. A battery needs a capacitor. A battery needs now the source. Yeah, we need to use a DC voltage source. Okay, for the resistor, this one is we have a leakage resistance here, and we have a equivalent resistance. This I can now rename. You can say this one is leakage. Okay, leakage resistance. Then we have the equivalent. This is the battery circuit. Maybe you can do some more research on the battery circuit. I won't go into deeper details of how we model a battery, but just know if this is the source of 100 voltage, you don't get, if this is the 100, you don't get the actual 100 because you have the resistance inside the battery, and we have a leakage resistance. Then the capacitor is used to store charge. Therefore, the capacitor, we're going to give it a 500 farad to demonstrate the charge. In fact, let me use 5,000. That's the charge already stored. Then this one I go to use 0.005. Then this one I'm going to use the one is common one is 0.0.01 resistor. Okay, you can do more research on the values why I'm using a 0.005, but for now is just a demonstration. The leakage resistance is usually connected parallel to the capacitor. Then the equivalent resistance is connected in series with both leakage and capacitor. Then we need this minor negative. This is my negative, and this one is my, you can drag a line here to be positive. Therefore, if you measure here, you can't get 100 because of the leakage resistances. But here is where we connect the load. The load is connected here. Okay. Therefore, let me drag it a little bit. This one is a battery. which is this battery here. Let's now connect the load. We have a time varying load, and we are going to use a resistor and which is a variable resistor. Therefore, you go to library elements, you choose look for a variable resistor here, Control R to rotate that. What happens here is the value for the variable resistor is usually a 0, the minimum value, but we can be able to vary the resistor. The reason is called variable resistor from maybe certain value, maybe 20, maybe after 10 seconds, resistor is 50. We can be able to vary this. And I'm going to include a deductor here. I won't go to deeper details where I'm using a deductor. Okay, that is connected in series with the variable resistor. I'm going to use a 0.1 Henry. Therefore, this is my load, and I need a negative terminal to be connected here. Okay, then positive terminal to be connected to the positive port. This is the battery. This is the load. Okay. Oops. Therefore, we need to provide a value of resistor to the variable resistor. We have to provide a value to the R. Okay. And I'm going to use this signal builder. I'm going to use this one I've already prepared. You can just type signal builder here. You can go to Simulink sources, or you can go to Simulink, go to sources, you look for a signal builder. You can have a step, sine wave, ramp, but we need a signal builder. Here it is, this one. We can maybe do some quick googling on how to use this one. So let me give you a quick demonstration. This one means simulation is taking 10 seconds. You can see the time in seconds, and the amplitude of the value is 1. I can change this to be, you can just click here once. Instead of 1, I can use 10. You see now this changes to 10. Here, you can click this point here. Instead of 6, I can also use 10, like that. Okay, so sorry, here at Y. This means at time 4 to 6 seconds, the value, assuming this one is I'm assuming this one is my resistor, resistance. I'm assuming, therefore, from 0 to 4, we'll have a 0 resistance. Then from 4 to 6, the value becomes 10. Maybe from 6 to 10, I can change this maybe to make it 4. This one to be 6 and 4, like that. Maybe the resistance now reduces linearly until from 4 to 0. We can have this type of signal that is being inserted to R. Therefore, I have already prepared one. Let me just copy it here. Save time. Let me double click. The same concept. My value of R, I'm going to use 1,000 seconds simulation so that the battery amperes hour can reduce significantly. From 0 to 100, the value of R is 20. The resistor of the variable resistor will be 20 from 0 to 100. Then from 100 to 200, the value drops from 20 to 5, that becomes 5 ohms. Then goes to 15, go to about 7, go back to 20, 10. You can see it is not a constant. The reason why it's called a variable resistor. If the 20 is a constant, it becomes like this. This is a constant resistor, but this one is a vary. You have to vary. Therefore, I will attach. This one is a Simulink. Therefore, you have to convert from Simulink to physical. Therefore, just write as Simulink to physical here. Remember, my first video illustrated how you convert back and forth from one form to another. Okay, therefore you connect it there. Therefore, I'm going to use allow Z second here, such that the value of this will keep changing depending on the value provided by the signal builder. Resistance value is here. Okay. Then remember we need to monitor now remember voltage. We need to monitor voltage. We need to monitor power and charge. How do you get power? We know power is a product of current and voltage. Therefore, we must measure the current and voltage so that we multiply them and get the power. Power equals VI. Okay, I go back here. Let's now measure the current. I'm going to put my current resistor here. Therefore, let me drag this back a little bit like that. Then I need to go back to library. We go to Simscape. Here and use electrical sensor and use a current sensor. Therefore, then I'm supposed now to have to delete this branch and connect the current sensor like that. Okay. Then this value, let me go try to rearrange a little bit. Then this value is we need now to convert this value to Simulink back FPS to Simulink. That's the converter. If we need this value, now this value is a Simulink signal of the current. Okay. Now we need now to measure the voltage. Okay, remember we are supposed to measure voltage here. Voltage across resistor, variable resistor. Therefore, let me rearrange here a little bit. I want to rotate this like that. I want to put it here. I want at least to rearrange a little bit like that, so that yeah, that's better, because I want to put my let me just go back how it was. Let me go to voltage sensor. I wanted to put the voltage sensor here directly. Therefore, take V positive, attach it there. Then Control I to swap V and negative. Then the negative go back here. Remember, we need to monitor the voltage drop across the variable resistor here. Okay, varying like that, varying resistor. This V is also a physical signal you convert back. Okay, right now we are getting the value of current here and value of voltage V and A. Okay, we need, how can we get power? Power is VI. And remember, these values are per second. This is the current in per second. This is voltage per second. Therefore, if you multiply current and voltage, you get power in watts. That is joules per second. Therefore, we need we go to math operators. can go to commonly used block. I want to use a product. I'm using a product here. I want to multiply current here. Oh, okay. Let me take this instead. I want to multiply current with voltage like that. I want to multiply those two. Okay. I want to multiply current here. This is the, let me name this signal. This is the current I, uh, current I multiplied by voltage here. Okay, let me just use an annotate. Voltage V. When you multiply these two, what do you get? V times I, you get power. Therefore, you need a scope to display the power. You need power like that. Therefore, this is, oh, oops, that is a power in watts. Power in watts. Remember, this is per second. Therefore, for us to get this power, we need to multiply V times I. Okay, that is power. Then we need to monitor voltage. That one we can now monitor the electric here. You just have another one here, another branch on this line like that. Because this is a voltage branch, you can now monitor it like that. Okay, this one is a voltage in V. Okay, now very important section, charge. Okay, remember my battery charge is that 3 amperes hours. Amperes hours. Therefore, we need to convert this current here. The current is in per second. We must convert that current to hour. Therefore, I need, what do I need? You go back to library, I need again. I'm going to use again here. Okay, again. I'm going to tap the current value here. This is the second. We need to convert second to hour. That's again. Therefore, how do you convert seconds to hours? Multiply by 1 over 3600. Therefore, the value we are going to get here is the current per hour. Okay, and we know that we know what is the value. How do you get current? Current is charge. Current. Let me get the value of current. I know that current I is the same as charge divided by time. Okay, because I know Q for charge the same as current times time. Current times time. I. Okay. Sorry. We know that Q for charge the same as current I multiplied by time. This is the value of getting the charge. Therefore, from the Q equals IT. We have I and T is our thousand. How can we get Q? Therefore, Q is IT, but we need to determine now current from Q. Therefore, how do you get a current from Q? You just get integral. If you integrate current, with respect to time, you get Q. Okay? Remember dq, let me write some integral here. dq divided by dt is the same as current. When you start now calculus, dq dt equals current. How do you get q? Therefore, q will be equals to integral of I dt. Therefore, q equals integral of I with respect to time dt. I hope you have understood the concept. Just know that Q equals IT, but you need for us to get now the charge here, we need to integrate current with respect to time. Okay, therefore you go back to the browser. I'll use integrator 1/s here, like that. Therefore, the integrator here, we are saying that the initial value is 33 amperes hour. Therefore, this will be 33. That is the initial value, 33. Then leave these ones as default, just like that. Okay. If you integrate this value, if you integrate current with respect to time, you get charge, and then you can be able to display the charge. I hope you have understood that section. Why we are using 1/s? It is because we need to integrate the value of current. This is a current here. This is the value of current. Remember, we are tapping the current. You convert that to hours. Then we integrate the value of current here to get Q. Because we know that dq over dt is the current. If you want to go reverse, it is an integral. Okay. Then we need a solver, like that. And I said solver, you can attach it anywhere you want to attach it. And then we need a electrical reference. Okay. By now you already know what is this. I like attaching my electrical reference to negative terminal most of the time. And we are done. And now you can comfortably run the simulation. Let's see. Okay, let's go to the scope and get the values. Okay, let me maximize here. Let me change this ones to 3 layout here, like that, so that each can be displayed on its own screen. Okay, then we need okay, this is weird. Let's see what's happening. This is 0. Okay, let's see what's happening. A minute. I want to determine what's happening here. This one is 100. Okay, then we are using a 0.01 to 9. That's fine. For this one is supposed to be 0. That's fine. Okay, then this one's supposed to be, let me check it. Okay, I know the reason why. Yeah, supposed to be a negative. Yeah, it's a negative. I will illustrate why it is a negative. Let's see the results. Yeah, I, you can see now the initially the charge of the battery was 33. That is initial state of our simulation. Then the charge starts dropping until we reach 1,000 seconds, and the value is around 29.3. You can see now the power generated here is proportional to the resistance. You can see the power. You can see the voltage. Let me open the graph for the signal builder and do the comparison here. Okay, this here. Let's see. Let's do some quick comparison and see what is happening. Higher at 20, this is the power. When the resistance is very high, the power is small. At this point, the resistance is the smallest. Okay, resistance is the smallest. Therefore, power increases. The power increases to there's no remember the power reduces due to the resistance of a material. Therefore, the smaller the resistance, the higher the power. This makes sense. Okay? And you know that the smaller the resistance, VI, Ohm's law, the smaller the resistance, the smaller the voltage. The higher the resistance, this point, yeah, where at between 400 and 500, this value here is high. You can see that now these graphs make sense. Yeah, that's how you model a battery that has a time varying load. Thank you so much. Now I have to reveal my next project. Since I have already illustrated basic principles of Simulink, we will start now modeling we are going to start modeling a car, that is a diesel car and electrical car. I'll illustrate how you can be able to model a car, how you can be able to to for example, these are the parameters you'll be using in our car, and we can be able to simulate what happens when a car is moving, when a road has an inclination of 2 degrees downward. Then we are going to we are going to start from a flat road with a 0 degrees. Then we vary the inclination from negative to positive and start analyzing the car parameters. Then we'll see the effect of when you are moving and there's a lot of headwind and a tailwind. We are going to measure the speed of the car, and you are going to model this car in Simulink and do some optimization. Okay, these are very interesting videos I'm going to make from my lesson 5. Kindly keep in touch. We will model a car, do the simulation here with you. It will be a fantastic project. See you. Bye.